there students, this is Doubell, your maths teacher, and we're going to quickly look at squaring binomials. It's pretty much grade 9 revision, and it's going into the grade 10 work, and we're going to quickly start at the beginning. If you have a binomial is just two values. When you add it together, you essentially create a new number. For example, 3 plus 4 would be 7. And if we had to say 7 squared, it would produce me 49. But if I had to just leave it in that form with the two brackets, 3 plus 4 times 3 plus 4, and if there's a dot or if there's no dot indicated, those two brackets are implying that they are to be multiplied together. But nonetheless, if we do not multiply them, but if we just keep them in those two separate sections, 3 plus 4 and 3 plus 4, once it is multiplied in a certain way, say when I say 3 times by 3 creates me the 9, 3 times the 4 gives me the 12, 4 times the 3, 12, 4 times 4, 16. Now, it looks a bit odd, but once it is applied like that, when it's multiplied out, it still yields you the same result of 49. 3, 3, 9, 3, 4, 12, 4, 3, 12, 4, 4, 16, added 49. So, moving on, if I had to say a plus b squared, in this case there are two unknown values, then a plus b multiplied with a plus b. Now, variables meaning was again that it's a number, a represented value that we do not know what it is. But a is not b. For example, 3 plus 4. There are two separate values. Now, a plus b and a plus b in their brackets still nonetheless is multiplied out just like the previous example, where we say a times a is a squared. A times b yields me ab. We can't simplify that further. B times a, you can also say, is b times a, but it's also a times b. Just as 3 times 4 and 4 times 3 is the same thing, ab and ba would be the same. That's why they would accumulate. When I say ab added together is twice ab. And then finally, b times b is b squared. So in total, we've got a squared, 2ab, and b squared. That's the simplest form for the squaring the binomials. But when you have a difference of squares, on the other hand, that's when the two brackets are not the same as in a plus b, But imagine you've got an expression as it's a plus b and a minus b. For example, 3 plus 4 and 4 minus 3. Now, once again, the exact same thing is applied. A times a produces a squared. A times minus b is minus ab. B times a is ab. And b times minus b is minus b squared. Now we can see that the middle terms minus ab and ab, once it's accumulated, it's like saying minus 3 and plus 3. They cancel each other out. Those two fall away because they neutralize each other. A squared minus b squared is the simplified form. So the reverse is also applicable then. Then therefore I can say that if the brackets a plus b and brackets a minus b simplifies down to a squared minus b squared, then a squared minus b squared is also to be expressed as a plus b, a minus b. And that is the summary.